In this video, we're going to look at solving quadratic equations using the square root property. Let's talk about all those words a little bit here. We've talked about solving quadratic equations. To understand what a quadratic equation is, I'm going to first start with the type of equations we have been solving. The equations we have been working with are called linear equations. And you can identify a linear equation because there's nothing happening to the variables except addition, subtraction, multiplication, and division. So the only operations that are happening with the variables are addition, subtraction, multiplication, and division. If it's just a regular number, it can have any operations. So basically what that leaves out is exponents and radicals. So with linear equations, none of our variables will have exponents, nor will they be under a radical. That brings us to what a quadratic equation is. With quadratic equations, we raise the power on the variable to a 2. So quadratic equations involve squaring the variable. So we still don't have any radicals, and we don't have any powers higher than 2. But we can have a variable that has a square. So the highest power that's on any of the variables will be a 2. And that makes it a quadratic equation. If we went up, it would be a cubic equation, and then quartic, and so on. But for this, we're just going to worry about the quadratic equations. So solving equations where the highest power on the exponent is a 2. Let's look at an example. So here we want to solve using the square root property, and I'll show you what the square root property is by working through this example. We have x squared equal to 9. Now we've talked about that to solve something is to find the solution or the value for the variable that makes the equation true. Now, so then the question becomes is what number squared would give us a 9? Well, that would be a 3, right? So I'm just going to write that over to the side. That's something we already know is x is 3, and we'll just leave that over there, but now we'll learn the technique of the square root property. But another thing that I want to point out is that the often forgotten solution there is x equals -3. So if we take a -3 and square it, we get a 9 as well. So both of those, 3 and -3, are solutions to this equation. Alright, so let's go back to the equation and learn a technique, kind of like we did with solving the linear equations, because these are going to get more complicated and we need to know a technique to use, and so a strategy. And so looking at that, x is being squared, so what we talked about when we worked with linear equations is we need to undo that squaring. And the way you undo squaring is by square rooting, because you're always using the opposite operation to cancel out the operation that is. So I'm going to go in here and I'm going to square root the left side because I want to undo the square. I'm also going to square root the right side because whatever I do to the left, I have to also do to the right. Now when I do that, I get x equal to 3. The problem with that is that while x equals 3, it also equals a -3. And when we solve these equations, we want to not neglect to find that -3. And so this is where the square root property comes in. Basically, instead of square rooting the 9, we're going to find both the plus and minus version of that square root. And so then our answer is both a +3 and a -3. So what I've written there, x equals plus or minus 3, that is shorthand for x equals 3 or x equals -3. Those mean the same thing. It's just the plus or minus symbol squishes that down into a more concise way of expressing it on paper. So that's basically what the square root property is instead of this rule that we're used to when you square root one side you have to square root the other, the idea is that we have to introduce this positive and negative square root to make sure we're getting back to the negative root that something could have came from when it was squared. And so the square root property tells us that if x squared equals to b, then x equals to plus or minus the square root of b, or x equals positive square root of b, and x equals negative square root of b, if you wanted to write that out the long way. So that's all the square root property says, is that when you square root both sides, you have to insert a plus or minus. And it really doesn't matter which side you insert it on, but it makes the most sense to insert it on the side that has the numeric value, since we're trying to isolate x or get x by itself. Let's look at another example that's not quite so simple. Alright, let's say we have x squared equal to 12. The reason why this one isn't as simple is because 12 is not a perfect square, but we still have this idea to undo the squaring on the x, we need to square root both sides. So that's going to give me the square root of x squared on the left, and then for my square root property, I'm going to plus or minus the square root of 12 on the right. The square root of x squared is just an x, and then the square root of 12 is 2 square roots of 3, and the way that ends up getting written is plus or minus 2 square roots of 3. Just like that. You could also say x equals 2 square roots of 3 or negative 2 square roots of 3. Alright, let's run through another example that complicates it a bit further. Let's say we have x squared minus 5 equals to 10. Now with this, what we want to do, you absolutely do not want to just square root both sides. Okay? That we do want to square root at some point so we can undo the squaring on the x squared. However, to square root both sides, you have to square root the entire side. Whatever you do to one side of the equation, you have to do to the other side. You can't pick and choose which pieces you're square rooting. So the only thing we want to square root on the left here is the x squared. But the property doesn't allow me to do that. I have to square root the entire side, and because of how our operations are structured, we can't distribute out a square root to individual terms. So we can't then just square root the x squared and square root the 5. You can't do that. And so essentially this problem gets stuck at this point. And so we don't want to square root this yet. What we want to do is get the squared piece by itself on either side of the equation. Here it'll be on the left side of the equation, but we want to get it by itself, so it's the only thing on the side of the equation that's with it. So to do that here, I'm going to add 5 to the left. Consequently, I have to add 5 to the right. That gives me x squared equal to a 15. Now it's just back to like we did with the previous example. And so I can square root both sides. I'm going to square root the left, and then I do plus or minus the square root on the right. Now on the left, that simplifies to an x. On the right, that doesn't simplify at all. So I'm just going to leave it as plus or minus the square root of 15. So there you have it. Basically, if you have more than an x squared on one side of the equation, you have to get it, you have to isolate the x squared. I like to say isolate the monster and then take it out. So get the x squared by itself and then undo it. And it'll work out that way. But if you try to square root something with multiple terms on the same side of the equation, that's not going to work. Alright, let's get really fancy here with our last example. We have the quantity of x minus 3 squared plus 10 equal to negative 4. Now here, sometimes it's tempting, you want to kind of simplify this square piece. You don't really want to do that. That might be the temptation, but you don't really want to do that. That's a square, and so if I square root it, then I'll get down to just x minus 3, which would be really nice for that whole squared thing to go away. So what I want to do here is the same thing I did in the previous example. I'm going to take this square and I want to isolate it as if it were just an x squared. Remember, when the parentheses are wrapped around something, we treat it like it's just a number, like we treat a variable like it's just a number. So we can go through this problem with the same process we did in the previous problem, understanding that grouping is just one number. So that means I need to start by subtracting 10 from both sides. That's going to give me x minus 2 quantity squared equal to a negative 14. And then I'm going to go ahead, now my squared piece is by itself, and so I'm going to square root both sides. So I'm going to square root the left and then plus or minus the square root of the right. Now on the left, when you square root a square, you just get what's under, or what's being squared. So here it's going to be an x minus 2 that you're left with. And on the right, now the 14 doesn't simplify any. It only contains a 2 and a 7. But the negative we're going to simplify to an I. So we'll get plus or minus I square roots of 14. And then we can add our 2 to go ahead and finish off getting x by itself. So that gives us x equals 2 plus or minus I square roots of 14. And it's customary to write the 2 in front as the real number and then the plus or minus part second as the imaginary piece. So that's what you do with that complicated guy. Go ahead and give some of the examples a try and see how you fare.